Hi there! Welcome to Science Made Simple by Ms. Flums. For our second 9 weeks coverage, we have the unit on energy transfer and conservation. We have discussed already the forms of energy and energy transformation, and you can always visit the pre-recorded YouTube video for these two topics. Last week, I have talked about potential and kinetic energy, and I am recording this other video to give you more information about potential and kinetic energy. For today's standard, 6P38.2, I can develop and use models to exemplify the conservation of energy as it is transformed from kinetic to potential and vice versa. You say vice versa, the opposite of kinetic to potential, and that is potential to kinetic energy. So our verbs are developed and used. That means you're going to make your own model, or you're going to use the model presented so you can exemplify how energy is being conserved as it is transformed or changed from kinetic to potential and potential to kinetic. Our cross-cutting concept, system, and system models. I have here a video on backyard roller coaster, which you can watch in our Discovery Education textbook. So please feel free to log into your Discovery Education textbook and watch that video about backyard roller coaster, and it will tell you how kinetic and potential energy works in that roller coaster. We have here a Venn diagram of kinetic versus potential energy. It's showing you the similarities and the differences between these two types of energy. Both of these are types of energy, and they can transform from one type to another. But the difference is that potential energy is present in stored energy. These are the energy in objects which are not moving, and the energy that is increasing based on the position and its height. Whereas kinetic, this is the energy of motion, and kinetic energy increases as the motion of the object increases. I will be showing you a simulation thanks to the Fed Colorado Education for this free simulation application that is very useful for you to visualize kinetic and potential energy. So look at here our legend. The green color is for kinetic energy, and the blue color is for potential energy. The orange color is for thermal, and this like a yellow-green color is for the total energy. So if you notice, this girl here is on top of the track, and you can see here that there is the entire pie. For example, this is 100% of the energy, and at the highest part of the track here, the girl is possessing 100% potential energy. So I want you to observe as this girl goes down. As she goes down, this potential energy is gradually converted to kinetic energy. As she reaches this part here, all the blue in here from the start, which is potential, is now totally converted to kinetic energy. And observe what will happen to the potential or kinetic energy of the girl as it goes up again to the track. Observe. So the kinetic energy in here is now converted to potential energy. And once she reaches again the highest peak of the track, that kinetic energy here now is now converted to potential energy. Now I want you to look at this part here as the girl goes down and up again. Observe what will happen to the kinetic and potential energy and the total energy present in here. So observe as she goes down, potential energy is decreasing while kinetic energy is increasing. And observe the total amount of energy is not changing. As she reaches this part here, all of the potential energy is now converted to kinetic energy, yet the total amount is still the same. As she goes up, that kinetic energy again is decreasing and the potential energy is increasing. And there you go. Alright, oops. So, you see that? So once the girl reaches the upper track here, all of the kinetic energy has changed to potential energy. As she goes down again, the potential energy is converted back to kinetic energy. So this is now a very good example of the conservation of energy. Energy is not created nor destroyed, but it is converted or transformed from one form to another. In this case, kinetic and potential are just being transformed from one to another, or from kinetic to potential, and vice versa, or potential to kinetic. Yet the total amount of energy is still the same.